Hello students, welcome to a new week and welcome to another class on chemistry. Today we'll be looking at Boyle's Law. Boyle's Law states the relationship between volume and pressure of a given gas, and it was first stated by Robert Boyle in 1662. And this law states that the volume of a given mass of gas is inversely proportional to its pressure, provided the temperature remains constant. According to Boyle's law, volume of a gas increases as the pressure decreases and vice versa. This relationship is independent of the nature of the gas, and it can be expressed mathematically as V inversely proportional to pressure, where V is the volume of the gas, and P is the pressure of the gas. Now, mathematically, we can state that by introducing our constants, so that V equals to K over P, or PV equals to K. PV equals to K. This means that for a given mass of gas, the product of its pressure and its volume is always a constant. Therefore, if the pressure of a given mass of gas increases, its volume will decrease by a significant proportion, and vice versa, as long as the temperature remains constant. Also, we can represent this expression mathematically as P1V1 equals to P2V2, where P1 is the pressure of the gas at V1, while P2 is the pressure of the gas at V2. Remember, the relationship between pressure and volume, according to Boyle's law, is an indirect relationship. We call it indirect proportionality. So mathematically, you can state that Boyle's law is P1V1 equals to P2V2, where P1 is the pressure of the gas at V1 and P2 is the pressure of the gas at V2. Graphically, we can represent Boyle's law this way. This is P1, P2, P3, P4, and this is V1, V2, V3, V4. So this is the graphical illustration of the Boyle's law. As you can see, as the pressure is increasing, the volume is, as the pressure is decreasing, the volume is increasing, and vice versa. Now let's solve a question here. It says 375 cm cube of a gas has a pressure of 770 millimeter mercury. Find its volume if the pressure is reduced to 750 millimeter mercury. Now, to solve this question, the first thing we need to understand that we need to look at the variables involved in this question. So we have pressure and volume. So that means we are looking at a pressure and volume relationship. So we'll be using Boyle's law equation, where P1 V1 equals to P2 V2. Here now, from the question, our P1, our volume, first volume is 375 cm3. Then our P1 is 770 millimeter mercury. While we are asked to find V2, we don't know V2, but we are given P2, which is 750 millimeter mercury. So establishing the variables in a question will help you know the type of equation you have to use. So since we have pressure and we have volume, so we are using Boyle's law. And this is the Boyle's law equation that says P1 V1 equals to P2 V2, where P1 is the pressure of the gas at volume at V1, and P2 is the pressure of the gas at V2. Remember that Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. So I said previously that when the pressure of a gas is increasing, the volume will decrease. So looking at this question now, the pressure is 70 millimeter mercury, and the second pressure is reduced to 750 millimeter mercury. So that means that the volume we're going to get, our V2, will be higher than V1, using or going by the Boyle's law. Now let's carry out our mathematical operation. We have a variable P1 is 770 times V1 375 equals to P2 750 times V2. So we're going to make V2 the subject of the equation. V2 equals to 770 times 375 over 750. By the time we carry out the calculation aspect of it, we arrive at 385 centimeter cube. So our volume at 750 millimeter mercury is 385. So this now has proven Boyle's law, because as the pressure is reduced, the volume increases. So thank you for watching this video. We'll see you in the next tutorial video. Thank you.